The next question says, use transformations of y equals 1 over x or y equals 1 over x squared to sketch the rational function. Find all the intercepts and the equations of all asymptotes. So in order for us to graph with transformations, we have to know the starting graph. So if we take a look at our function, which is f of x equals 1 over x plus 3, I need to know what the graph of just y equals 1 over x is first, before I can do the transformations. So I'm going to start by graphing by plotting points so I can figure out what the picture looks like. And I usually choose a standard set of points, -2, -1, 0, 1, and 2. However, notice that 0 is going to be a problem. If I try to substitute a 0 into this equation, I would get 1 over 0, which is undefined. So I'm going to take the 0 out, and because I can't choose 0, I'm going to choose some numbers that are close to 0. I'll choose a -1/2 and a +1/2. You're going to substitute that into the equation, so that would give me 1 over -2, which I'll call -1/2. Substituting a -1 in, 1 over -1, that's -1. 1 over -1/2 is the same thing as 1 divided by -1/2. When we divide fractions, we multiply by the reciprocal, so that's 1 times -2 over 1, so that's -2. 1 over 1/2 is the same thing as 1 divided by 1/2. That's 1 times 2 over 1, which is 2. 1 over 1 is 1, and 1 over 2 is 1/2. So now I have some points that I can plot to get an idea of what the picture is going to look like. My first ordered pair is -2 and -1/2. -2 and -1/2 would be about right here. Maybe I should use a different color. -2 and -1/2. -1 and -1, -1/2, and 2. 1/2 and 2, 1 and 1, and 2 and 1/2. Now, these 6 points don't look like they connect to each other. They don't follow like a smooth path, and that's because of what we talked about earlier. Remember we said that we couldn't plug a 0 in? So because plugging a 0 in would give us something that's undefined, we have a break in the graph, and that break happens at 0. And that break is also the vertical asymptote. So if we think of having a break along that y-axis, we can connect these 3 points together, and it makes sense, and connect these 3 points together. We also have a horizontal asymptote that happens along the x-axis. So we have both a horizontal and a vertical asymptote. The horizontal asymptote happens at y equals 0, and the vertical asymptote happens at x equals 0. So going back to the problem we're actually trying to graph, remember we're trying to use transformations to graph 1 over x plus 3. Now that plus 3 is a vertical shift. It's going to shift all of these points up 3 units. So when it shifts it up 3 units, that's going to take that horizontal asymptote that was at 0 and move it up to 3. So now we're going to have a horizontal asymptote at y equals 3 instead. So we end up getting a picture It looks very similar to the original one, just shifted up 3 units. So that's going to be this picture here. It also asks if we have, we want to find the Y-intercepts. You find Y-intercepts by letting x equal 0. If I let x equal 0, that's f of 0 is 1 over 0 plus 3. And notice I have a 0 in the denominator, that's undefined. So there is no y-intercepts. It also asks for x-intercepts. I'm going to have to erase a little bit here to get the x-intercepts, excuse me. How do you find an x-intercept? You let y equal 0 or your function equal 0. I'm setting the whole function equal to 0. I'm going to solve by getting x by itself, so I'll subtract 3 on both sides. Negative 3 equals 1 over x. You can get rid of that denominator by multiplying by x on both sides. I have negative 3x equals 1, and divide both sides by negative 3. That gives me x equals negative 1/3. So we have an x-intercept at negative 1/3. The next part says find the vertical asymptotes. Now remember in our picture we had a vertical asymptote at x equals 0. We shifted up 3. We still have a vertical asymptote at x equals 0. Find the horizontal asymptote. We started off with a horizontal asymptote at y equals 0. We shifted up 3, so now we have a horizontal asymptote at y equals 3. Thank you for checking out my videos. Have a great day.